how the sun was born, why it shines, and the mystery of nuclear fusion. Imagine traveling back 4.6 billion years, before Earth existed, before the planets formed, and before the sun lit up our solar system. At that time, there was no sun in the sky. Instead, there was a gigantic cloud of gas and dust floating through space. Scientists call this a nebula. Most of this cloud was hydrogen, the simplest and most abundant element in the universe. For millions of years, gravity slowly pulled parts of this cloud together. As more and more gas gathered in one place, the cloud became denser and hotter. Think of squeezing air into a tiny space. The temperature rises. The same thing happened on a massive cosmic scale. Eventually, a huge ball of gas formed at the center of the collapsing cloud. This young object is called a protostar. It wasn't a true star yet, because it wasn't producing its own energy. It was simply getting hotter and hotter as gravity kept compressing it. The pressure inside this growing protostar became unimaginable. Temperatures climbed into the millions of degrees. At the core, hydrogen atoms were moving so fast that something extraordinary happened. They began to collide with enough force to overcome their natural electrical repulsion. This was the birth of nuclear fusion. Nuclear fusion is one of the most powerful processes in the universe. In simple terms, it happens when small atomic nuclei combine to form larger nuclei. Inside the sun, 4 hydrogen nuclei eventually combine through a series of reactions to create one helium nucleus. But here's the amazing part. The helium nucleus weighs slightly less than the 4 hydrogen nuclei that created it. So where did that missing mass go? According to Einstein's famous equation, E equals mc squared, mass can be converted into energy. A tiny amount of mass transforms into an enormous amount of energy. This energy is released as light, heat, and other forms of radiation. The moment nuclear fusion became self-sustaining, our sun officially became a star, and it has been shining ever since. Every second, the sun converts around 600 million tons of hydrogen into helium. Out of that, about 4 million tons of matter are converted directly into energy. That may sound unbelievable, but the sun is so massive that it can keep doing this for billions of years. Now let's explore how that energy reaches us. The core of the sun is where fusion happens. Temperatures there reach around 15 million degrees Celsius. The energy produced in the core begins a very long journey outward. Surprisingly, a photon of light created in the core doesn't travel straight to space. Instead, it bounces around endlessly, being absorbed and re-emitted by particles inside the sun. Scientists estimate that a photon may take tens of thousands or even hundreds of thousands of years to finally escape from the sun's interior. Once it reaches the surface, called the photosphere, the journey becomes much faster. From there, sunlight travels through space at the speed of light. The distance between the sun and Earth is about 150 million kilometers. Even at light speed, it takes roughly 8 minutes and 20 seconds for sunlight to reach our planet. That means whenever you look at the sun, you're seeing it as it was more than 8 minutes ago. The sunlight that warms your skin today began as nuclear fusion deep inside the sun long before human civilization existed. Without this energy, life on Earth would be impossible. Plants use sunlight through photosynthesis to produce food. Animals depend on plants directly or indirectly. The sun drives weather systems, ocean currents, and the water cycle. Even the fossil fuels we burn today originated from ancient plants that captured solar energy millions of years ago. In many ways, nearly all energy on Earth comes from the sun. But the sun won't shine forever. Although it seems eternal from our perspective, stars have life cycles. The sun currently sits in the main sequence stage of its life. It has been here for about 4.6 billion years, and is expected to remain stable for another 5 billion years. Eventually, the hydrogen fuel in its core will begin to run low. As fusion slows, gravity will gain the upper hand and compress the core further. This compression will heat the surrounding layers, causing the sun to expand dramatically. It will become a red giant. At that stage, the sun could grow large enough to engulf Mercury and Venus and possibly even Earth. After shedding its outer layers into space, the remaining core will become a white dwarf, a hot, dense stellar remnant slowly cooling over billions of years. But that's a story for the distant future. For now, our sun continues its incredible work. Every sunrise is powered by nuclear reactions occurring deep within a giant sphere of plasma 150 million kilometers away. A star born from a collapsing cloud of gas now provides the light, warmth, and energy that sustain life on Earth. The next time you feel sunlight on your face, remember the incredible journey behind it. A journey that began billions of years ago inside a cosmic cloud and continues every second through the extraordinary power of nuclear fusion. If you enjoyed this cosmic journey, don't forget to subscribe to my YouTube channel for more fascinating science stories and space adventures.